Hi, and welcome to our next lesson. Today we're going to continue looking at the normal distribution and specifically how standard deviation works with it. Now, we have looked at standard deviation before, and what standard deviation is, it's talking about how far something is from the mean, how spread out our data is. Deviation, how far we have deviated from or how far away from our mean we are. This leads to the 68, 95, 99.7 rule. And I will explain that in just a minute, exactly what that means. So with our normal distribution, our mean is nicely in the middle of our normal distribution. So what that means is that it gives us a nice symmetrical distribution. 50% will be to the left or below the mean, and 50% will be to the right or above the mean. So if I had a collection of scores, if it's a nice normal distribution, half of those scores are below the mean and half of those scores are above the mean. If I go one standard deviation above and one standard deviation below the mean, I get an area in the center. Now that area in the center, that is one standard deviation either above or below the mean, will contain 68% of all my results. So if we have a population of scores, 68% of those scores will fall within one standard deviation above or below the mean. On the diagram there, if I've got 68 in the middle, because it's nicely symmetrical, the remaining 32% is going to be split up with 16 below that section and 16% above that selection. But in that one bit in the middle, which is one standard deviation above and below the mean, we're going to have 68%. Now, if I go out to two standard deviations, what that now means is that from two standard deviations below the mean to two standard deviations above the mean, I now have 95% of all my scores. So of a population, 95% will be within two standard deviations either above or below the mean. Again, being symmetrical, the remaining 5% is going to be split to 2.5% on that left tail of the diagram, and the other 2.5 is going to be on the right tail of the diagram, just those little bits on the side. Now, this is the 68, 95, 99.7 rule. So if one standard deviation gives me 68%, two standard deviations give me 95%. Hopefully you can figure out what three standard deviations is going to do. It's going to give me 99.7%. So almost 100% of my data will be within three standard deviations above the mean and three standard deviations below the mean. It's not quite 100%. There's always just that little bit that's beyond that, certainly with a large population. So what we've left is with 0.3%. So we're going to split that in half again. 0.15% is going to be below three standard deviations in that little tail on the left, and 0.15% of the population will be above three standard deviations in that little tail on the right. So let's look at a real life example, our results. So nicely, our class had a normal distribution of marks. We had a mean of 50 and we had a standard deviation of 16 marks. All right, so when we're talking about standard deviation, it's always in relationship to whatever our original data was. If we're looking at, let's say, heights of people in centimeters, our standard deviation would be in centimeters. If we're looking at time in minutes, then our standard deviation would also be measured in minutes. So in this example, our real life example, we had a standard deviation of 16 marks. So we know that our normal distribution is symmetrical. So that means half of the class scored above 50% and half of the class scored below 50%. Nicely symmetrical. So one standard deviation below the mean, so I've got a mean of 50 marks, and I take away one standard deviation of 16 marks. So that gives me the lower part of that one standard deviation section as being 34 marks. So that's one standard deviation below is 34 marks. Next thing is to work out what one standard deviation above the mean is. So I'm starting with my mean of 50 and I'm adding on my one standard deviation of 16. So that gives me 66 marks. So now I've got a region between 34 marks and 66 marks. And remember our 68, 95, 99.7 rule. What that means is that 68% of our class, 2/3, had scores between 34 and 66. Right, that's 68% of our class. That's where it fell. So then the next thing would be to look at 95%. Where are 95% going to fall? Well, that's 2 standard deviations. So what I'm doing is I can go 50 minus 16 is one lot of standard deviation minus another 16, or I can just go my 34 marks and take 16 away from that. But what we're looking is at 2 standard deviations. So that's 2 lots of 16, which is 32 marks. So I'm going to go 50 minus 32, and I'm going to go 50 plus 32. So 50 minus 32 is 18. 50 plus 32 is 82. So that means that 95% of our class scored between 18 and 82 marks. Now it's 95% because we do still have 2 students who aren't included in that range. Unfortunately, we had 1 student below 18 and we had 1 student successfully above 82. So that's why we don't have a full 100% there, because there are still 2 students outside of that range of 18 to 82. If we went now out to 3 standard deviations, because our class is only, I think it's 24, it's not that big a sample, so we're not going to have 99.7. At 3 standard deviations, we will have 100%. Right? Because we have a small sample, that 99.7 rounds to 100. So all of us in the class would fall in that 3 standard deviations above or below. All right, so that's a nice real life example. I was both surprised and more or less happy that we got a nice normal distribution, because that means that everything has been nicely spread out. And it's not a case of assessments have been too hard and everyone's failed, or everything's been too easy and everyone's passed. It's been a nice normal distribution. All right, example 2. So in a normal distribution, the mean recovery time after contracting a certain disease is 12 days with a standard deviation of 2 days. A, how long would it take for half of the patients to recover? Well, we know that our normal distribution is nicely symmetrical. So our mean is going to be in the middle, and we're going to have half above that and then half below that. So we know that our mean is 12 days. So how long will it take 50% to recover? Well, it's going to be 12 days. 50% below the mean, 50% above the mean. Mean is 12 days, so we're going to get half of them recovering in 12 days. Some might be less, but that's still within 12 days. B, what percentage of patients would recover within 8 to 16 days? Well, we know we've got a mean of 12 days and we've got a standard deviation of 2 days, so we need to work out where are 8 and 16. So 1 standard deviation above 12 is going to have 14, and 1 standard deviation below is going to be 10. 2 standard deviations, well, that's going to be 4 is 2 standard deviations, so 12 take 4 is 8, 12 plus 4 is 16, so that gives me that section of 2 standard deviations. And remember, 2 standard deviations lines up with the 95 from our 68, 95, 99.7 rule. So how many will recover between 8 and 16 days? Well, that's going to be 95% of our patients. There's going to be 5% that are still outside of those 2 standard deviations. So that covers those that are going to recover with less than 8 days, and those who are going to take more than 16 days to recover. C, what percentage of patients would recover within 10 days? Now, we've got our 10 days. There was 1 standard deviation, right? 1 standard deviation from the mean was 10 to 14 days. So if I just bring up a little diagram there, that's it there with our 1 standard deviation. The part that we are interested in is those patients who recover in less than 10 days. So our mean in the middle is 12 days. 1 standard deviation to the left is 10, but I want to know everybody who's less than that 10. So looking at that diagram, I'm talking about that shaded area on the left tail that says 16%. Because those represent the patients who would recover in less than or up to and including 10 days. So what percentage? It's that 16% on the left tail there, because that's at the lower end. D, if we've got 400 patients who have contracted the disease last year, how many would have recovered within 16 days? Now, our 8 to 16 days, that was 2 standard deviations. So let's change the diagram to represent our 2 standard deviations. We've got our 95% in the middle, but the question says how many have recovered within 16 days. So that bit in the middle is just 8 to 16 days, but I want those people as well who are less than 8 days. So it's going to be that 95% in the middle plus the 2.5% on the left, because all of that is less than 16 days. So we're going to do 95 plus 2.5. So that's going to give me 97.5%. But then I need to work out what is 97.5% of 400 patients. Right, so 2.5% plus 95%. Now remember, if you're doing this in a calculator, you're going to need to do 2.5 plus 95 equals 97.5. Divide that by 100 to convert from a percentage to a decimal, and then times that by 400. And that's going to give us 390 patients. So 390 patients last year not only contracted the disease, but recovered within 16 days. The other way that you could do this on a calculator is because it doesn't really matter where you divide by the 100. You could just do, well, 400 divided by 100 is 4, and then go 2.5 plus 95 is 97.5. 97.5 times 4 is 390 patients. You will get the same answer working that way. Example 3. The distribution of delivery times for pizzas made by Antonio's Pizza is approximately normal. So that's telling us that we have a normal distribution, approximately, with a mean of 25 minutes and a standard deviation of 5 minutes. So the first thing we want to do is draw a bell curve to represent the delivery time distribution. So when we come across that question, what we want to do is we draw ourselves that normal bell curve shape. But rather than just have mean and then 1 standard deviation, 2 standard deviations, we actually want to use the numbers. So in the middle of our bell curve, we are going to write 25. And then we're going to go up by 5 minutes and down by 5 minutes. So we're going to have 25 in the middle, and then we're going to go up to 30, 35, and 40. And then we're going to go down to 20, 15, and then 10. And we're going to get a diagram that looks like that. I've written in that 68% is what's going to be between 20 and 30, because that's our middle part of our normal distribution. The 13.5s on either end, if you go 68 plus 13.5 plus 13.5, that will all equal 95%. So that's just breaking down that 95% from 2 standard deviations above and below into those 3 sections. There is a section to the left of 15 and a section to the right of 35 that don't have numbers in them. If we need them, we can work them out when we get there. All right, but in essence, all we've done is we've drawn the normal distribution curve and then written in the numbers from the question. And that just has to be a sketch. Don't be too upset if your curve isn't perfectly symmetrical when you draw it. So then what percentage of pizzas have delivery times between 15 and 35 minutes? Now, because we've nicely written all of our times onto our bell curve, we can just read it straight off the diagram. So between 15 and 35, well, that's 2 standard deviations. So we just want to know what's between those 2 standard deviations. So you can add 13.5, 68, and 13.5, or you can remember that it's 95%, doesn't matter which. But that's our answer. 95% of all pizzas have delivery times between 15 and 35 minutes. That should say C, not B. What percentage of pizzas have delivery times greater than 30 minutes? So remembering that our distribution is nicely symmetrical, If I was to draw a line between 25 and 30, everything to the left of 25 is going to be 50%. Between 25 and 30, I've got half of that 68, so that's going to be 34. So everything to the left half is 50 plus another 34 is everything up to that 30-minute area. So if I go 50 plus 34, well, that's going to give me 84. That's everything less than 30 minutes. But I want to know what's greater than 30 minutes. Well, we've just worked out what the percentage of less is, so it's going to be 100 minus that. So that leaves us with 16% unaccounted for. So that's the percentage of pizzas that had delivery times greater than 30 minutes. All right, now you can, like I said, it's 50% is going to be to the left and 50% is going to be to the right of that 25 minutes. So you can say, well, we've got 50 minutes to the right minus 34, and 50 minus 34 is again 16. So it doesn't matter which way you go, you will still get the same answer. It's all about just working out what part of our normal distribution are we interested in finding. The normal distribution is on your reference sheet, that the bell curve with the percentages. So you don't have to remember that. You just have to remember what part of that diagram represents which part of specific questions. So that when you get a question like this, you say, well, it's the greater than 30 minutes, and you could shade in the section that represents greater than 30 minutes, if that helps you, to then try and work out what the percentage is going to be. And that says C, but really should be D. In 1 month, the House of Pizza delivers 2,000 pizzas. Now, assuming they have the same distribution as Antonio's pizzas, how many of these pizzas are delivered in less than 10 minutes? So remember how we had our 68, 95, 99.7? So that 99.7 covers every pizza delivered between 10 minutes and 40 minutes. So that left us with 0.3% for both less than 10 and greater than 40. So we want to half that to 0.15%. So 0.15% of all pizzas are going to be delivered in less than 10 minutes. And realistically, that should make sense, because think about, this is from you ordering it to how long it takes them to make it to then delivering it. 10 minutes, that's pretty quick. Your pizza wouldn't be cooked. So for whatever reason, we've got 0.15% of 2,000 pizzas. So you can go 0.15 times 2,000 divided by 100, or 0.15 over 100 times 2,000, or 0.15 times 20. It doesn't matter which way you get there, it's still going to be 3 pizzas. So out of those 2,000 pizzas, there's only 3 that were delivered in less than 10 minutes. And that brings us to the end of this chapter. Like I said, the diagram is on your summary sheet, and there is a copy of the summary sheet up on Google Classroom so that you can have a look and see exactly what it looks like if you haven't already got a copy in front of you from having printed it out yourself. As always, if there are any questions or if something's not 100% clear, please let me know. This starts to get a bit tricky at this point from the normal distribution. So we're going to be coming across lots of new terms and lots of new concepts. So by all means, let me know if something's not clear. If I can make it clearer, I really want to. So please let me know, either via email, or you could message me through my Google Classroom. Either way, I will get the message. But yes, by all means, please let me know. This is a new concept for you, and I do expect it's not going to make perfect sense straight away. So yes, please let me know if you need help. Now remember, Thursday, 26th of August, that should be this coming Thursday, depending on when you're watching this. 9:30, we're going to have a Zoom meetings for the class. So I will put up the class code probably around 9 o'clock, I'd hazard a guess, on Thursday morning. And then it will go live at 9:30. If I don't hear from you beforehand, I look forward to seeing you then.